I think we're good. I think we're now recording. Just stop sharing for a second. Yes, we're recording. Okay, I'll share again. All right. Just one more thing to be done. Presentation. All right, I hope everybody can see that. Yes. Again, use chat if you have any difficulties with anything that's happening right now. Okay, I think we're good. All right. So let's see. So as I said, I'm from the Department of Mathematics and Computer Science. My name is Sofia Chepushtanova. I know it's a long name. It's of Russian descent. My students call me Dr. C or Dr. Sofia. This is my 6th year in the department, and I really like my university. I really consider myself to be part of Wilkes, and I like my colleagues. I think we have great set of people here in the department, both mathematicians and computer scientists, and I will tell you about everything that we offer here in the department. All right, let me start from mentioning that Department of Mathematics and Computer Science is part of College of Science and Engineering. So it's a big college. There are several colleges at the university, as you may already know, and this is one of them. And in addition to our department, of course, there are many other departments that this school has. Particularly, we have chemistry department, biology department, different engineering departments, physics, earth sciences, health sciences, and so forth. We are located, our department, located on the 4th floor of the Stark Learning Center. As far as I understand, later or maybe earlier, you had a tour on the university. So they will maybe show you this building, either virtually, right? Probably virtually. And then we on the 4th floor, sometimes we also teach in classrooms on the 3rd floor of this building. Okay, so I'm going to be repetitive sometimes. I hope it's okay. So I'm going to start mentioning that the department programs are in mathematics, computer information systems, and computer science. And probably you already know that because you're here for this session. You're interested in one of these degrees. So what I'm going to start with, I'm going to say several words about why math, why computer science, right? Why computer information systems, just to maybe give you additional motivation in what you're pursuing, or maybe in addition to what you would like to do, you may consider a minor. Like for example, if you're really interested in computer science, you may consider a minor in mathematics or even double major with mathematics. So that would be great. Some students of our department do that. So why math? I think mathematics is an interesting, beautiful field on its own. And I'm a mathematician by education, right? I got my degree from Colorado State University. And I like to think about mathematics as a science of patterns. And usually when you hear that, oh, not you, but people hear that somebody says, oh, I like mathematics, I would like to build my career in math. So usually they consider that to be the only option, teaching, right? Oh, why do you need to do math? You're going to be teaching, right? But teaching is just one option. And teaching is great. I particularly tried teaching in graduate school. Only that was my first time, and then I never knew that it's such a great thing to teach. So I'm teaching now, and I'm doing research as well as a professor. But teaching is just one option. So in addition to what you can do with teaching either in secondary or school or at college or university, you can consider to be an applied mathematician working with different interesting problems in engineering, physics, biophysics, different networks modeling, right? To doing like very rigorous mathematical abstract research in academia or in some national labs. So, and mathematics is a tool and a science that's present in almost every academic discipline, which is very true. And at different levels, of course, right? From very simple ones to very complicated ones, but still, math is everywhere. And I like this quote. It was said by Nikolai Lobachevsky from Russia a long time ago. He said that there is no branch of mathematics, however abstract, which may not someday be applied to phenomena of the real world. And I can show you an example. I can tell you an example. So I'm particularly interested in doing topological data analysis or computational topology. If you never heard of topology in mathematical sense, that topology is um, mathematical field that studies shapes and continuous deformations between them, right? And it's a very abstract it's a very abstract field. But about 20 years ago, some algebraic topologists offer an algorithm called persistent homology that actually reveals structure in real world data. And it's very popular. So particularly my colleague, Dr. Lucent, and I, we're working in the field of biophysics, in particular protein folding. And we apply this very complicated and very abstract technique actually to reveal structure in data, like different high dimensional holes. And for example, zero dimensional hole would be how many isolated components you have in your data. So I believe very much in this quote, and I think math is very important. And with math degree, you can pursue a career in engineering, actuarial science, statistics, operational research, medicine, like for example, creating surgical simulators, computational biology, data science, definitely math preparation, especially if you consider yourself to be working in applied world with technology, very good, very strong math preparation and computer science skills. That's a great combination. Why computer science? It's very popular nowadays, right? The reality is that technology now is part of our lives and businesses and industries, and it's everywhere. Computers are everywhere. We cannot imagine our lives without computers, right? And it's a necessary skill set for any educated person in our century. But why computer science in general? It's not just because we want to use computer as a calculator, which as it started a long time ago, right? Now computers are used to solve very complex, challenging, multidimensional, life-saving problems, and we would like to have people who can do that, right? You're not necessarily just a programmer, you also need to understand the architecture of a computer, right? You would like to be sure to know how to optimize your code or how to optimize the performance of a particular computer system. So there's lots of different things you can do with this computer science. You can be a system administrator, right? And so forth. So, and in addition to that, computer science is very well paid, as well as mathematicians. They paid well as well, I would say. So there are many lucrative careers waiting for you in technology. So those jobs, they among the best jobs in America. So this is some interesting data extracted from the work by Anthony Carnevale from Georgetown University. And this information, I think it's several years old, but I think it's still actual. So mathematics and computer science among these most lucrative majors, right? Till now. Maybe that's partially why you're interested in them, right? And again, I would like to give you several interesting applications just to emphasize why math and computer skills are widely used and important, and why so many people are interested in getting those skills. So definitely having good math and computer science skills, especially this combination, it works very nice. So you can apply them to modeling some, doing some weather predictions, right? Creating some weather models. You definitely can apply all these math CS skills to financial fields, like particular do trading. You can do interesting research in genomic analysis. And of course, nowadays it's very popular what's related to security, like face recognition, even face emotion recognition, tracking a person in a particular location, and some other interesting applications related to recognition. And then, of course, video games, the video games design is very popular direction nowadays. Engine design, molecular dynamics, I mentioned that earlier. That's part of my research. And of course, robotics. In addition, it requires some good engineering skills, but still, math CS skills are a big part of it. I mentioned surgical simulators a minute ago, so yes. So different surgical models, movie making, animation, social networking, artificial intelligence, that all require math, good math, and of course, computer science skills. And of course, you know that new computer platforms, new smartphones, new gadgets appear every year or even more often. And then programmers, they definitely are involved into these fields that create all these new platforms for different applications. So some jobs in mathematics and computer science you may consider after you graduate. So you can pursue career in statistics, population research. You can be an actuary. You can be a data science. You can do math modeling for different applications, like for example, surgical simulators or robotics. You can do teaching. You can do biomathematics, bioinformatics. You can be involved in animation and game design, as said earlier. And your employer can be an oil company, bank, government agency, military, national lab, school or university, and so forth. Degrees at Wilkes. Again, I mentioned that already, like at the very beginning of the presentation, just to remind you one more time. So here we have, we offer degree programs in mathematics, computer information systems, and computer science. And currently in this academic year 2021, we have 17 math majors. That also includes 3 graduate students. We have 7 CIS or computer information system students, and we have CIS computer science students, which are the most popular, degree right now in our department. We have 4+ students there. Some of those students that you see, the numbers of which you see here, they combine in computer science with minor in math, which is easy to do if you're a good student. If you're a very good student, it's easy to combine math with either CIS or CS. And of course, I will show you what particular classes you need to take in each math, CIS, and CS, just to give you a general idea of what you're going to be taking in the course work. All right, so if you start from math major, as I started several slides ago, so we offer 3 tracks here. So if you're interested in further graduate study, research, some careers in industry government, if you're interested in teaching, in academia, I'm not talking about secondary school teaching because it's a separate track we have here, but this the most general classical mathematics track, that's what you need, right? But there's also another interesting track. It's called computational mathematics. And this is to prepare you to work in all fields of science. And this overlap with computer science degree. And for those who do a degree in computational mathematics, it's often easy to get either minor or even major in computer science at the same time. And I keep saying that it's a great combination, especially if you consider yourself to be an applied specialist in the future and technology specialist. Having a strong mathematics preparation and a good computer science skills make you very competitive at the job market. One of my excellent students is exactly doing this. He's a computational mathematics major and at the same time he's computer science major. And you will see later, I will show you classes, they overlap. So it's not that hard as it may seem to get double major. And the 3rd track here is teacher certification. It prepares you for secondary school teaching. So we definitely, every year we have students who prepare themselves to work as math teachers at either middle school or high school. So very briefly, so mathematics programs here are a Bachelor of Arts, Bachelor of Science. You can do minor in math, you can do minor in statistics, and recently we added actuarial science minor. So you're welcome to do this as well if you're interested in this. So the difference between BA and BS is that Bachelor of Arts is more expansive, like it just expands. It's not that focused on particular major. I mean, it still has the core related to major, like for example, related to mathematics, but it also has some additional, I would say it's a little bit less relaxed program. It has some additional classwork that is not linked so strongly to the major. While at Bachelor in Science, it's strongly focused on subject major. So you have to take more math classes there. And usually if you consider your coursework, your studies seriously, I think usually people pursue Bachelor of Science. All right, math curriculum. So if you in standard track, this is the list of classes and electives to take, right? We require our math students to take calculus 1, 2, and 3, differential equations, set theory and logic, linear algebra, abstract algebra, real analysis, all this classical, all the math courses that every mathematician must know. And in addition to that, we also require to take CIS 1, it's computer science first level class, just to give you some preparation and some at least little set of computer science skills you may need in the future. And there's a great general offer of electives in math here, including geometry, statistical methodology, linear programming, complex analysis, numerical linear algebra, which is my favorite actually. So yes. And computational track, as I said, it overlaps with computer science. So we have rigorous core with math courses, right? You have to take, including calculus of all levels, differential equations, linear algebra, abstract algebra, real analysis, numerical analysis, and all these things. But in addition to that, you also need to take all computer science courses from level 1 to 4, C and Unix. You need to take algorithms and some electives. You see them here again, complex analysis, geometry, linear programming, operations research. In both computational track and standard track, you need to do senior presentation. I will say a couple of words about that as well. So master's degree provides foundation for advanced degrees in computer science, statistics, engineering, business, management, data science. So I think I keep repeating this. Sorry if I sound repetitive to you, but I think math preparation is very important for all these directions. So as I said, mathematics senior seminar. So in your last year of studies, you will need to do 2 seminar presentations. So it's going to be fall semester and spring semester. At the end of fall semester, you do presentation 1, and at the very end of your year, you will do semester 2 presentations. So you choose topic of interest, you do a little of research, you partner with a mathematical faculty to understand the material, to present the material, and you just present, right? You present, you deliver clear presentation, and you should be able to answer questions asked by faculty and the audience. And there's some past math seminar presentations. You don't have to do that for minor in math, but if you're doing double major, for example, if you're a computer scientist, you want to do double major with mathematics, you definitely need to do this as well, right? Okay, I don't know. There are 3 listeners to me today. I don't know how many of you guys interested in computer science and mathematics. You let me know after the presentation. Computer science and computer information systems, if you were waiting for this, so here where we are going to talk about this. So again, so those skills are very important in different businesses, in research, educational, and industrial environments. And of course, it's not just about, oh, I like technology or I like play video games, right? When you pursue career in computer science, you need to understand that you still need to have strong math background. You still need to have take lots of computer science courses. It's lots of work. But let's see. So here, let's start from computer information systems, and then we will finalize with computer science. So in computer information systems, the career question that you're trying to answer, right, when you study for this degree, what technology would work best, right? So we have here a Bachelor of Science and minor in computer information systems. So what technology would work best means that here you're a specialist who use computer systems to tailor them, to design them for particular business or industrial organization, right? So you either write software or modify software, and you tailor the system, database, software to fit business needs. So in addition to that, you will need some expertise in business as well. And then why this particular degree requires taking some business courses. I will show you the list of courses in a minute. right? So you're going to be, when you're working as a CIS specialist, you interface with engineers and programmers to design systems to meet business requirements, right? I hope that makes sense. So what technology works best? So you need to take systems analysis, system design, computer programming, analytic and business areas pertinent to the development, implementation, and maintenance of information systems. So this is basically what describes computer information systems in general. And particularly, as I said, in addition to computer science courses, which will be listed in a minute, so here you also have to take accounting, managerial finance, management of organizations, management foundations, and some electives like marketing, production and operations management, and so forth. This is like essential part of this degree. So required computer science courses for CIS are all levels of computer science from 1 to 4, C and Unix, web development, mobile applications, software integration, systems analysis, and computer networks, databases, and you also do senior projects. I will say several words about senior projects as well. So CIS electives, you also can take linear programming, operations research, web development too, some CS electives to your taste, and business electives to your taste, or to your interest. Finally, computer science. As I said, that's the most popular degree in our department, which is understandable, right? Many young people nowadays want to be computer scientists. So the classic, the only classic computer science program that we offer here that are split into Bachelor of Science or Bachelor of Arts, or you can also get minor in computer science. So, and again, most students, they usually do Bachelor of Science. And career question here, that why does the technology work? You actually need to use a particular technology or create a particular technology or program particular technology just to answer some applied questions. So what you need to take here: computer science 1 to 4, C and Unix, analysis of algorithms, architecture and design, software engineering, operating systems, and bunch of electives like programming languages, compilers, science requirements. They may include some taking labs in either chemistry or biology. So actually it's also part of mathematics and CIS requirement. So, but then they vary, of course, for different degree. And you also have math requirements here. You have to take calculus 1 and 2, you have to take discrete math and some other interesting math courses. So in both CS and CIS, you have to be involved into senior projects at the very end of your studies at the department. So during your last year, you need to create a software and present the software to a committee. And here you see some past senior projects, like course rosters. By the way, course rosters here particularly, we use this rosters program at the university. When you see the rosters of students, particularly it's used mostly by faculty, and some students helped us to modify them, to make them better, right? It was a project. It can be some games that you design, game simulations, robotic chess, some mobile apps. So anything that interests you. Yeah, mobile apps. This is just one example. And in addition to your core CS coursework and some math requirements, I think we offer a pretty good collection of courses you can take. Right. Yeah, I'm sorry if some information on this slide seemed to be repetitive, but I think it doesn't do harm, right, to see this information, to understand better what we offer in here. Some job placements. So for job placements, what we have in our past graduates, they are involved in different interesting organizations and labs and businesses. So particularly we had graduates who work at IBM, Lockheed Martin, San Diego National Labs, Intel, Google. I remember one student was graduated and he got to Amazon. He was a very good student. So you definitely can get wherever you want, but you have to work hard for that. So you have to be a good student. We also have departmental facilities. So on the fourth floor here of the Stark Learning Center, we have our own server. And the server allows us to provide 25 workstations in our lab. So all the computer science courses, or some of the computer science courses, they are actually held in this lab. They're Linux-based machines with Windows in a virtual machine. So there are some other technical specifications here. And in addition to that, we have another room with 8 computers, were usually used by students for work and for homework and for labs. All right, so what else? This is the list of our faculty members. So since it's a joint department of mathematics and computer science, you can find here mathematicians. So we have this list of mathematicians. Since mathematics is required, so math courses are required to be taken by many, many programs at the university. So we have to have lots of faculty to teach those basic math courses here. And here's the list, including myself. So we also have computer science and computer information system faculty here, but there's also some universal faculty who can teach both math courses and computer science courses. So here we are. Our Stark Learning Center, if you've never been to Wilkes, and when you come to Wilkes, so in the Stark Learning Center, we recently had some redeveloped labs and renovated labs. So what we have here is advanced manufacturing, nanotechnology, bioengineering, and computer simulation and visualization stations, all labs. We got some money for this several years ago. In addition to that, and I was part of that team, we applied, we proposed, and we actually got awarded by National Science Foundation. We got $500,000 to acquire a high-performance computer cluster. We going to use this computer cluster to support student faculty research across a variety of science, engineering, and mathematical disciplines. We already started doing that. This last summer, I was involved in some undergraduate research, and we were trying to store and work with our data using this cluster. And then under this pandemic situation, of course, we did everything virtually. So we're now living in a different world. Okay. Undergraduate research that I just mentioned, I'm interested in doing undergraduate research with students. And again, it doesn't have to be pure math. No, if you're interested in some pure math questions, you're welcome. But I consider myself to be applied mathematician and really like doing that with my colleagues, interdisciplinary colleagues here. So particularly Dr. Lucent, he's my partner in crime here. And what we do, we working with some interest in biophysical problems. And if you're interested to work with us, so you have to be a good student, you have to acquire some math and computer skills. And of course, we teach you lots of things. And of course, you have to be curious. And there's another list of information about where our graduates go, right? This is just some particular names, particular people that went to different interesting organizations and institutions. So among this list, you see Naval Air Systems, Google, we have NASA, we have PhD program students, like the recent two, they both my advisors, they went to, Lindsay wasn't my advisor, but I worked with her on her senior presentation. So Simon and Lindsay, they went to PhD programs. So Wilkes can be just the first step in your career, and then you can continue with software engineering program or with math PhD program somewhere else. And I think it's a good combination to start at a small school, because here you get a very close attention and very close, have very close relationship with your professors here. They know you by name. You can ask any questions. You can come to their office hours. You directly communicate with professors versus to big schools at which you communicate with TAs very often, the teaching assistants, and you don't see your professor very much. But here, I think what I like about small schools is this, right? You have this very direct, very close communication with the professors, and then later, when you graduate from our school, you can go and already experience yourself in teaching, doing research, if you're interested in further studies, right? Some people, what they do, they graduate from our university and then work a little bit, right? And at the third and the fourth year, they're trying to find some internship. And for one of my students, for recently it worked, right? He worked as an intern and then he got a job there. So that happens too, happens pretty often. Sometimes we have this, what we call them, academic fair and job fairs. So you can find job even here at the university. I'm not sure how it's going to be happen under the pandemic restrictions, but I hope that that will improve soon and we will be back to normal life soon as well. So currently what we have, guys, we have this interesting combination of classes. So we open physically, right? We teach. I particularly teach face-to-face. I know that some professors, they teach online only, some professors online in some hybrid format. So some classes, they physically meet in the classroom and some classes they done online only. So it depends. So we had some freedom in here. I personally like face-to-face classes very much because it allows me to communicate with students and ask questions and answer questions, right? While online, it's just you have to rely on technology very much, which can be all right, but I think it's just missing a bit when you do online only. Okay, so let me mention very quickly, like I just typically just use several, I apologize. So I'll just use several minutes to talk about a couple of other things that we have here in our department. So we have this ACM computer programming contest in Mid-Atlantic region. And we've been hosting this contest since, I don't know, I think it's probably started somewhere in the 90s. I may be mistaken, but definitely very long before me. And we were winners from time to time. So here we have first place in 2003, third place in 2012, later in 2015 and 2016. So it's a contest for computer scientists to create some software, to create some computational answers to questions in math or computer science questions. And then just you have some time restrictions and you have particular number of problems to solve. Right? So you can be involved in this. We also do integration bee contests every year. Unfortunately, our last one was canceled due to the pandemic of COVID, but otherwise, I think it's a very fun event. It's not necessarily for math students. We had engineers, we had computer scientists, we had many other people interested in integration, and I think it was very fancy and people were happy to participate, right? There's our recent winners. And we also have Math CIS Club. Again, under this restrictions recently, wasn't very active, but maybe when you come to us, you will be interested in doing some student activities, participate in discussions, doing some fundraisers, participate in national science events, field trips, that all possible to be done, provided that you're interested in doing that. All right, so here, what you see is my email. You can easily find my email on the list of faculty members of our department. So you can just simply type wilkes.edu, and then you will find mathematics and computer science department, and you can easily find my information about me there, information about our co-chairs, Dr. Brecken and Dr. Harrison. And now I think it's going to be a good time to start talking about what you have for me, any questions, any concerns. So if you don't mind, I will stop sharing right now. And I allow you to unmute yourselves. Guys, you're welcome either ask your questions via chat, or you can just unmute yourself and ask your question. Any questions? No? No questions? If you want, I can also type one more time my email. Just a second. Right, you can copy that, and later, if you have questions later, you can definitely email me. I would be happy to answer your questions anytime, so absolutely. So it can be questions about the program, it can be questions about, I don't know, particular class you would like to take. So anything right now? No? All right, then if you don't have questions, I think that's all I had for you today. Now it's 11:38. We still have plenty of time. I don't know, now you're going on the tour, right? Okay. All right. Then we can just end our session if no questions come in. And I wish you good luck. Either you already decided what you're going to do at Wilkes, or you're still thinking about what degree you would like to pursue. Again, let me know if you have any questions. Good luck with everything. I hope that very soon we will be back to normal. We're still open, right? You see, it's already 5th week next week. So it's going to be, yeah, it's going to be 5th week. We started the end of August, and so far we still open and we conducting classes. So I hope that we will be able to finish this year without being shut down. So this is our hope. All right, guys. So if no questions, yeah, there is a questions. No, it's just thank you. Oh, you're welcome. Thank you very much for attending my session. All right. Okay, so I have Lauren, Roy, and David. Good luck with everything. And no questions, right? One more question about questions. No. All right. Okay, then that just email me, and good luck with everything, guys. Thank you very much.